Welcome to all in examples. This is the magnetic effect of current and magnetism, and we are here to solve the problem that is based on this topic. We have covered all the topics, subtopics related to magnetic effect of current and magnetism. We have also solved the problem topic wise. In this lecture, we will solve the quality problem, which will increase our intellectual level, which will increase the depth of topic. And the chances of these questions will be more in exam. Means there is a chances that you will see this type of question or the concept based on these questions. In this question, we have given that consider a straight wire of circular cross section. Okay, and it's of radius A, and you're carrying steady current I. The current is uniformly distributed to this cross section. We have to find the distance from the center of wire cross section at which magnetic field is half of the maximum possible magnetic field anywhere due to the wire. Clear? This is the situation. So you have a long straight wire of circular cross section, radius A and I. So you can say this is your wire of circular cross section. Simply if I draw this, see, this is a two views. You can say this is a front view of wire, okay, which is of the radius A, and this is the top view of the wire which is of radius A, obviously. Okay, same thing is there, but thus view are different. So the current is uniformly distributed across this cross section. We have to find the distance from the center of wire of the cross section at which magnetic field, that is inside and outside both, is half the maximum possible magnetic field. Okay, so if you understand this, you know what is the maximum magnetic field is at its periphery. So if it's a long straight, means a infinite wire, so V maximum will be mu naught I over 2 pi A. Simple. But the question is demanding that you need to find the distance, okay, where the maximum magnetic field is half. So half of it, half the maximum magnetic field, it is going to be mu naught I upon 4 pi A. Simple. Now just I'll draw this because you know very well that for the graph, if I draw the graph of this, and this graph represents whole scenario, and the graph is between magnetic field B and R. So this is the extreme position, you can say A, periphery. So inside it is, the graph is like this, and outside it is inversely. So when I talk about inside, so B magnetic field inside is going to be mu naught I over 2 pi A square into R. Simple. Now as you know, this much is equal to the half of the maximum, and we have to find that position, okay, for inside. So for inside, you know, B inside is mu naught I over 4 pi, sorry, it's 2 pi A square into R, but it is equals to half of the maximum, that is we have already find mu naught I over 4 pi A. Just cancel them, whatever cancelled out, pi A mu naught, and it's 2 times also I. So your R will become A by 2. This is for inside. For outside, okay, as you know the graph, outside means This is your wire cross section, A radius, and something out here. Okay, so this is R, which is given by simply mu out mu naught I over 2 pi R, but it must be equals to half of the maximum, which is mu naught I over 4 pi A. So from here your R is equals to 2A. Okay, so it is given the pattern is like this. First you have to write inside, that is A by 2, then comma, then outside, that is 2A. This is your answer. In this question we have a solenoid situation and the magnetic field inside is given, that is 2.9 into 10 to the power 4. Okay, now turns are also given, radius 10 centimeter is given, your current 0.29 ampere is given. What we have to do, we have to find the length. So magnetic field due to solenoid, okay, magnetic field due to solenoid, and that is inside I am talking about, is given by B equals to mu naught N I. What is N here? Small n, that is number of turns per unit length. Okay, so can I say this N is equals to N by L? So magnetic field here is given, that is 2.9 into 10 to the power minus 4 equals to, what is mu naught? So can I say it's 4 pi to 10 to the power minus 7. What is N? Small n, that is N over L into what is I? I is here 0.29. And if you look at the problem, the number of turns is given 200. So this is 200. From here, your L can be easily determined, which is going to be 8 pi centimeter. In this problem, your current wire is given. First try to understand the problem, then we will see the solution also. Situation is like this, that you have a current wire, okay, a long current wire, so it's obviously infinite. 1, 2, 3, okay, like this. This is your infinite wire, and a particle of mass m and charge q is released, okay, at a distance a from the wire. So you can say this point, and also it is clear that the speed is along the direction of the current. So if the current direction is upward, your speed is also upward. So let's say this point A, which is at distance small a, and the direction of the speed is along the direction of the current, say B naught. Is it okay? Now the particle get attracted to the wire, obviously same direction, opposite current will be flow, then due to the opposite nature of current flowing in the direction, opposite nature of current flowing in the wire,